Here is an explanation for the answer to final exam question number 54 in Trigonometry Demystified, 2nd edition. Please refer to page 378. When we say that the dot product operation is commutative, we mean that for any two vectors r and s in 3 space, one of the following equations holds true. Which one? And then we're given A, B, C, D, E. Well, the dot product of vectors is indicated by a big bold dot, and the dot product is also known as the scalar product because it results in a real number or a scalar quantity. Scalar means real number, basically, like the square root of 72 or something. Anyway, in this particular presentation, I have used half arrows over the letters to indicate vectors. In the book, we use boldface. Sometimes you'll also see full arrows like that. But what does the commutative property mean? Well, as you have learned in algebra and arithmetic, if you have an operation, let's call it at, then commutative means that you can transpose or commute the order of the quantities and get the same thing. So, for example, addition is commutative because for all real numbers x and y, x plus y equals y plus x. Multiplication is commutative. In general, though, subtraction and division are not commutative. But the dot product of two vectors is commutative. That simply means that for any two vectors r and s in 3 space, r dot s equals s dot r. Choice C is the answer to this question. A little bit simpler, you may want to also look at the video that explains the answer to the previous question number 53, which deals with the cross product, which happens to be something called anti-commutative. A similar and yet different property. But again, the answer to this question is C.